Okay, class, today we're moving right along in our graphing unit. So today we are going to be graphing more linear functions. We're just going to be graphing today in point slope form. Okay, so we're adding a third option of how we can graph. Sorry if you hear a bunch of pounding, there's construction happening right outside my room. Okay, so point slope form, just like the others, has a general form. So our general form for point slope form is the longest of all of them that we're going to look at. It is y minus y sub 1 equals m times x minus x sub 1. Okay, and just like slope-intercept form, it's not named very creatively. So if it's named point slope form, hopefully we're not that surprised that the two things that we can find from this are a point and a slope. Good news, slope is still represented by the letter m. So we're still going to find our slope right here in front of this set of parentheses with the x. Now, we have two x's and two y's happening in each of these. The x and y that do not have the subscript of the 1, those are the ones that stay permanently in the equation. So this is going to appear as the letter y in the equation. Okay, whereas the x sub 1 and the y sub 1 are what make up our ordered pair. Okay, so our point is x sub 1 comma y sub 1. Now, the problem is that not that this is hard, there's just this piece we have to be able to pay attention to. A, they're backwards order, right? The x comes first in our ordered pair, but it's last in the formula. The y comes second, but it's over here sort of first. Also, notice that this formula has subtraction signs in it. That subtraction sign is part of the formula. So we've talked about a couple ways that we can read this, right? We can read this as subtraction, or, right, we can also read this as a negative, but we can also read this as the word opposite, right? This tells us to take the opposite sign of whatever. So when we are finding our ordered pair of x1 and y1, we need to use the opposite sign of what it looks like. So if it looks like a -4 in the equation, it's a +4 that we're going to write down in the ordered pair, right? Because this is part of the formula, not part of the ordered pair. So we need to make sure we're always taking the opposite sign of both the x and, oops, not saying opposite sign, of both the x and y value. So if we can keep those two things in mind, then we're pretty home free. Okay, so let's say we're given y minus 4 equals 1/2 times x minus 2. Okay, the two things that we can find are a point and a slope. The slope is the pretty straightforward one, right? Slope is what's sitting in this m position right in front of the parentheses. So our slope is going to be 1/2. Now our point, again, is x comma y, where we are always taking the opposite sign. So if it looks like a negative, I need to write it down as a positive. So it's going to be a +2 and a +4. Yes, let's look at another one just to make sure we're okay with that. How about y plus 7 equals -2 times x minus 1. Okay, the slope we do not take the opposite of. There is no negative up here in front of my m, so my m stays as the sign that I see it. So this is going to be a -2. My point, I do take the opposite sign. So it looks like a -1, I'm writing a +1. It looks like a +7, I'm writing a -7. Okay? Now, once we have that information, we can then graph this. So to graph in point slope form, it's going to be almost exactly the same as graphing in slope-intercept form, which is what we looked at yesterday. Okay, the first thing is we're going to find the important information. right? We're going to find the point in the slope. Which we've already done up here. The second thing is that we are then going to plot the point. So we don't have a B to plot today, but we do have an ordered pair that we know how to plot. Okay, so once we get that point plotted, just like yesterday, we're then going to count our rise over run. And we're going to count that from the point, not from the origin, not from a place on the X or Y axis, unless that point happens to be there, right? From the point that we plotted. So if I want to graph, I'm doing these same two equations that were in our notes. So I'm just going to take these and now I'm going to graph them. So if I want to graph y minus 4 equals 1/2 times x minus 2. The first thing I'm going to do is find the important information. So we already said that our slope is 1/2 and that our point is 2, 4. So I am going to plot the point 2, 4. Now here's where students get tricked up. Again, I didn't write the rules, so don't blame me. Ordered pair is x, y. But now when we go to plot our slope of rise over run, now we do vertical and then horizontal. So they're sort of flip-flop in the order we go in. So we have to be a little bit careful that we don't get those backwards just on accident. Okay, so from this point, I'm going to go rise of 1 and a run of 2. So I'm going to go up 1 over 2. And just like before, I'm going to count that twice just to double check. And there's my line. Okay, so our second one was y plus 7 equals -2 times x minus 1. We have a slope of -2. And we said our ordered pair, right, is a +1 and a -7. So I am going to plot the point 1, -7. So 1, -7. Now I want my slope to be a fraction, just like yesterday, and it's not. So I need my rise over run. So I'm going to put that over 1. Right? This is really a -2 over a +1. So I'm going to go down 2, right 1. But uh-oh, I run out of space to count that again. So same idea that we did yesterday. We said if it wouldn't fit, we would change the sign of each of these. So that -2 is going to become a +2, and my +1 is going to become a -1. And again, that's something you don't have to write. You could just sort of see that, okay, I want to continue the line this way, right? But now I'm going to go up to left 1, and there is my line. Now let's just look at one odd maybe situation, right? Of maybe we have something like this. Y plus 4 equals -x. Okay, so our m is always the number in front of parentheses. So our number right here is really a -1. Our point, we have to think a little bit more about because we don't see a number inside with the x, right? So that number that we're really subtracting there is a 0. 0 doesn't get a positive or a negative. Our 4 looks positive, so we will make it negative. So in this situation when we graph 0, -4, right, we do end up on the intercept. And we get that y-intercept. -1 over 1, right, down 1, right 1. And negative slope should always be going downhill anyways, so we're good. Okay. Then last thing I want to talk about is doing this sort of in a reverse order, right? Introducing the idea that what happens if instead of me giving you the information, me giving you the equation, you finding the important information in the graph, we sort of go in reverse, right? What happens if I tell you, okay, what about if my m equals 3 and my ordered pair is -2, 5? Can I then write the equation of this line? And to do that, right, I'm given a point and a slope, so it makes sense that I should be plugging into point-slope form. So point-slope form, right, I'm just taking that general form, where my ordered pair is my x sub 1 and my y sub 1. So I'm going to say y minus my y sub 1 is 5 equals m, which is 3, times x minus x sub 1, which is -2, right? This subtraction is from the formula. This negative is from the 2. Now, we wouldn't really leave it that way, most likely, of subtracting a negative, right? We know that 2 negatives actually make a positive. And so we would have y minus 5 equals 3 times x plus 2. Okay, likewise, if we were given that information on a graph, okay, and maybe we were given this, right? We can't write the equation of this line how we learned yesterday because we don't have a nice, neat y-intercept. So we can't find b. So now we need to sort of find that important information, avoiding finding an intercept. But we could find a point, and we could find a slope. And this works no matter what. If you don't see that there's a good y-intercept, you could always go this way and then be like, oops, there was one. Okay, so slope we know how to find. Slope we do rise over run. Up 1 over 2. Okay, then we're just going to name any old good point that we see on here. So I don't know. Here's a point right here. I name it as 1, 2. Okay, so I looked at my graph, I pulled out my information, and now I'm going to plug it into point-slope form. Right? I'm just doing everything that I was doing in reverse order. So y minus my y sub 1 is 2 equals m, which is 1/2, times x minus x sub 1 is 1.